Hello everyone, welcome to the third International Conference on ICT for Development of Africa, in particularly to this presentation. My name is Nsaid Adresa, and I am one of the research team members who participated in this research. And I am currently working in the Commercial Bank of Ethiopia. And our research is all about route quality measurement methods in mobile ad-hoc network. In the next 15 minutes, we will discuss about the motivations behind this research, the methodologies that we followed, and how we will also see how we converted the problem domain into mathematical models. Then after that, we will see how we transformed our mathematical models into simulation scenarios. And finally, we will also see the results that we found from our simulations and the ways that we validated the significance of the results that we found from these simulations. Finally, we will conclude by discussing about the key takeaways from this research. So basically, there are three key points behind this research. The first one is the need to consider additional network parameters in the routing process. As we know, AODV and other mobile ad hoc network protocols only consider route length in the routing process. But what we want is a mechanism to consider other parameters, such as remaining energy of nodes, the delay between communicating nodes, and other parameters. So the first point is that we need to consider such parameters in the routing decision process. The second point behind this research is the need for a generalized path quality measurement method. The parameters that we mentioned earlier can be recorded separately in the packet headers. However, this can lead to an increase in the packet size as we increase the number of parameters that we need to measure. So what we want is a generalized metric that can indicate quality of nodes that are in the network. The third point behind this research is the need for justification to choose between two competing route quality measurement methods. Namely, these are the summation and the multiplication methods. Different researchers have used either one of these two methods. However, what we want is a scientific justification to choose either one of these two route quality measurement techniques. So these are the three key points behind this research. By basing upon the motivating ideas that we mentioned earlier, we have developed mathematical models and tested these mathematical models against the process of selecting the base route and avoiding loops. Then we converted these mathematical models into simulation scenarios. The simulated mathematical models are evaluated against their set of predefined performance evaluation criteria. So the results that we found from the simulations are again validated to see if there is a significant performance improvement in our methods. This is basically done by using hypothesis tests. So the conclusions are based on this set of procedures. The two competing route quality measurement methods that we mentioned earlier, namely the summation and the multiplication method, are represented by these two equations. So when we try to calculate the quality of a path by using the summation method, we are simply taking the average weights of nodes along that route. On the other hand, when we apply the multiplication method, we are simply multiplying individual weights of nodes along that route. But what do we mean by the weight of a node? When we refer to the weight, we are simply referring to the quality of that node. So the quality of a node can be affected by two sets of network parameters. The first group has a positive relationship with the network performance, and the second group of network parameters are inverse relationship with the network performance. A good examples of such parameters are node remaining energy of nodes and packet loss ratio of individual nodes. So the weight of a node is simply the difference between these two groups of network parameters. To further investigate the difference between the two methods that are the summation and the multiplication method, we have set up two cases where in case 1 we have two routes R1 and R2 with equal route lengths, but the nodes along each route have different weights. So when we apply the summation method to these two routes, the result is the same. That means the summation method assumes these two routes to have the same quality. On the other hand, when we apply the multiplication method, we get two different results. That is, the multiplication method assumes route 1 to be more stable than route 2 because nodes along route 1 have relatively stable weights. On the second case, the routes R1 and R2 have different lengths, but nodes along each route have the same weight. So when we apply the summation method, the value that we get is the same, despite the fact that route 2 is the shortest path. However, when we apply the multiplication method assumes route 2 to be the best route because it is the shortest path from the source node to the destination node. So as shown in these two cases, the multiplication method is good at identifying the shortest and the most stable route between the source and destination nodes. After mathematically comparing the two methods, we have converted them into simulation scenarios by using the network simulator version 3. There were 36 different simulations, and the resulting dataset has 26,970 data items. The performance evaluation criteria for the two methods were average throughput, average end-to-end delay, and average packet delivery ratio. These are some of the simulation parameters that we used during our simulations. Initially, there were 50 nodes, and throughout the simulations, we have gradually increased the number of transmitting nodes, and throughout the simulations, we have also increased the packet size and the maximum node speeds. But what are the results that we found? We will see them in the next slide. When we compare the two methods in terms of average end-to-end delay, this is the result that we found. As shown in the graph, the summation method has higher average end-to-end delay than both the multiplication and the AODV protocols. As we know, the total delay of a node is the summation of processing and transmission delays. So, the observed difference is mainly due to the added weight averaging logic in the summation method. And when we compared the two methods in terms of average throughput, again the summation method had higher average throughput than the multiplication method and the AODV protocols. However, throughput and packet delivery ratios are interrelated properties. So, we should expect the summation method to have higher packet delivery ratio than both the multiplication and the AODV protocols. As expected, the summation method has higher average packet delivery ratio than both the multiplication and the AODV protocols. This result satisfies the relationship between throughput and packet delivery ratio. So, these are the three key observations from this research. Next, we will see how we validated the significance of the performance difference that we observed from the simulations. To further investigate the significance of the observed performance differences between the two methods, we have applied hypothesis tests. In particular, we have used t-tests. During our tests, we considered significance level of 5% and confidence level of 99%. We represented the null and alternative hypothesis in both descriptive and mathematical forms as shown in this slide. And these are the results that we found. The key point is that out of 100, 99% of the times when we compare the two measures in terms of packet delivery ratio, the observed performance difference is less than 1%. So this observation led us to the following conclusions. So these are the three key takeaways from this research. 1. The multiplication method is good at identifying stable, short, and loop-free routes. 2. The multiplication method has lower averaging time delay than the summation method. 3. The multiplication method has approximately the same packet delivery ratio as the multiplication method. This is because 99% of the time the two methods have a performance difference of less than 1%. So with that, I would like to conclude my presentation and thank you for your time.